In previous lessons, we've talked about methods or functions that do a particular task and then they return. They don't actually return any value. However, there's something called a value method. It just means it's a method or a function that returns a value. For example, when we looked previously at the math square root method, that obviously returns a square root. It's going to return a double. If it didn't return it, it would be pointless. You don't want to just print it out. Sometimes you want to calculate something with it. So it makes sense to have a return value capability for when you're talking about functions or methods. Okay, so an example of this is here's a declaration. Here's a declaration of something that calculates the area. It will calculate the area of a circle. It will return a double. The previous methods we looked at right here, instead of double, it said void. That was a method that just performed some task, maybe printed something out, and then it just returned. It didn't return any value. In this case, it actually returns a value, the area of the circle that's been calculated. Okay, so what we have here, well, let's just look at the absolute value one. The absolute value one, it's actually determining the error, meaning the expected value you should have gotten, subtracted the difference between the expected value and the actual value when you're calculating something, and it returns a double. You assign that into this error val. Okay, you don't want a negative. You don't want a negative error. You just want to know the distance. And that's really what absolute value is. Okay, the body of the method must have a return statement. Previously, we didn't need a return statement because it could just fall off the end of the code and then it'll return to the calling function. However, in this case, it has to have a return statement because that's how you supply the return value. So you see here, return resulted. It'll calculate the area. Pi times radius squared is the area of a circle, pi r squared. I store that in result. I could return the result. I could have also done something where instead of return result, I could have just put return pi math.pi times radius. I could have put that right here. Normally, it's better to do this where you have like what's called sort of a temporary variable where I store what the radius is and then I return it. That's good when you're actually building or compiling or designing the function. That's what we talk about here. It's called incremental development. You might want to do that for debugging purposes. If you're trying to debug, you might want to print out result before you return it to make sure this function or this method is actually working correctly before you use it to do other things. So that's called incremental development. When you're a little bit more experienced at coding, you wouldn't need this intermediate step. You would just get rid of this, put the return up here, do return math.pi times radius. It's much more concise that way. Okay, here's an example of an absolute value function. Again, it's going to return a double. It returns basically whatever you gave it, but the positive version of it. Okay, so it says if x is negative, if x is less than 0, in other words, negative, change the sign and return it. If x wasn't negative, it must be positive, so just return x itself. So that's an example of the absolute value function, and it returns a double. Here's where it returns a double. If I had to change a sign, here's where it returns a double if I didn't have to change a sign. Okay, we talked a little bit about incremental development. Method composition is when you're using one method or you're writing one method and you use other methods within it. When you're trying to design a program, it makes sense to come up with what methods or functions you need first, what their return values are, and what the parameters are. That allows you to see the design kind of at a glance. You see what methods you have, how they interact, and it makes it very easy to debug because you can debug the smaller methods, be sure they work, and then when you're using them in the bigger methods or the higher level methods, you know that at least what you got back from the other methods are correct. So it's a good method for debugging as well as design. There's an important feature of Java called method overloading. We talked about operator overloading. Remember, the plus sign can mean add two numbers. It could also mean concatenate if you're talking about strings. Method overloading is when you have a method that has the same name as another method, but it actually does something different. So the way Java would tell which method you want to call is based on the parameter list. So suppose I have two methods called circle area. I'm trying to calculate the area of a circle. Everyone knows we need the radius to calculate the area of a circle. If I have the radius, I'll call this one. I'll call the one that just says circle area, all I need is a radius. And remember, up above, all it did was do pi times radius squared. Okay, so that one's pretty straightforward. But what if instead I have a circle that's on a Cartesian coordinate plane? I have the x1, y1, which is the center of the circle, and I have x2, y2, which is a point on the circle. So I have coordinates for that circle. Now, you still need the radius to calculate the area of that circle, but if I'm calling this circle area, instead of determining the radius first by doing the distance between 2 points, between x1, y1 and x2, y2, remember the distance formula from geometry? If I was going to call the same circle area with radius, I would have to calculate this radius first and then call this circle area. Instead, I could combine this, so I make a new method that takes two coordinates. This coordinate, x1, y1, x2, y2, which again, one is the center, one's on the circle. And this circle area will first do the distance formula to determine the radius, and then it will determine the actual area of the circle by doing pi times radius squared. Okay, and some of the other ones that are in the math library we've looked at previously, math.absolute value, it can take an integer or it can take a double. So that's another example of operator overloading. So let's take a look at some examples from chapter 6. We talked about calculate area, which takes a radius and calculates the area of a circle, pi times r squared. In this example of that function, I'm first storing the radius in kind of a temporary variable here, and then I do the return. Remember, that's what you're doing. That's what you do when you're building the function and you're debugging it. Because if you're debugging, there's two ways you can do it. Go into a debugger, dump out result, and see if it did it correctly. Or right after this statement, you could put a print statement that prints out the result, and you could verify that it's correct before you actually return it. Once you're sure it's working, or if you're more experienced, you could just do this. Make it much more concise. Just do return pi times r squared. Okay, we talked about the absolute value function. We're going to see how it works, but remember it returns a double and it takes a double, and it just changes the sign if it's negative, otherwise it keeps it just exactly how it was. Now this is an example of incremental development of the distance method to compute or to perform the distance formula on two coordinates, x1, y1 and x2, y2. We talked about how that might be necessary if you're trying to calculate the area of a circle, but you're only given two coordinates, the center and a point on the circle. So when you're first starting, this is what distance one method does. All it does is first decide, oh, what's the difference between the two x's. Remember, the distance formula is x2 minus x1 squared plus y2 minus y1 squared. We could do that all in one function, which is done later, but instead we're going to build it incrementally. So we first see, I find the distance between the two x's, the distance between the two y's. Did that work? Did I get the right x2 minus x1? And did I get the right y2 minus y1? I print them out and I see. I return a 0 to show me that that's my one that it's building. I'm not really ready to do anything with it. Now my next step, once I figured out that these two are calculated correctly, now I'm going to square them. So I print out what's squared. Again, I'm returning 0 to make sure I know to myself that this is not the complete one yet. So I'm almost there. Now, the final distance formula, which does everything, is it first does x2 minus x1 and y2 minus y1, squares them. And remember, the final step in doing the distance formula is to take the square root of the answer. That's what I do here. And then I return the result. So that's complete. That's the complete distance formula given two coordinates. The other two I don't really need anymore. Okay, so to define circle area, first thing I'm going to do here is this is one where I'm giving two points, an x and a y, and another x and another y. So this is the center. This is the point on the circle. First I calculate the distance. Then I can call calculate area because that distance is my radius. So I can do calculate area given the radius. Okay, this one kind of takes a shortcut because instead of having this intermediate thing called circle area, it just calculates the area because it calls calculate area with radius, but it's more concise this way because it calculates the distance first to determine the radius, and that's automatically the argument to calculate area. So that's kind of a more concise version of the function. So we're going to look at what some of these do. I'm going to calculate the area two ways. Remember, one was where I had the intermediate variable or the temp variable, and I returned the temp variable. The second one, I just do it all in one statement. And then I have two circle areas that I'm going to show you how they work. This one, remember, it did distance formula in two. It did the distance formula, then called calculate area with that radius value. This one did it in one step. Oh, here's absolute value, and then we can just look at what the different distance formulas determine. So we'll just see what happens when we run that. Okay, so let's look up. I'm going to have to page up a little here. So the first thing I did was try to calculate the area of a circle with a radius of 3. This one did it in two steps. Remember, it figured out the area and stored it in a variable, and then it returned that variable. This one did it in one step. It just did a return of pi times radius, or pi times r squared. Got the same exact answer because it does the same thing. One was just coded more concisely. Okay, the next one tries to find the area of a circle that has 2 points. The points are 1, 2, that's x1, y1, and 4, 6, that's x2, y2. Now remember, when you do the distance formula, you'll find the difference in the x's. So the difference in the x's is 3. 1 minus 4 is 3. The difference in the y's is 4. 2 minus 6 is 4. So really, when I do the distance formula between those two values, it's really the Pythagorean theorem. So if the distance between the x's is a 3 and the difference in the x's is a 4, it's really a 3, 4, 5 triangle. It's a Pythagorean triple. So I know the radius should be 5. And when I calculate it, I should get 5. Let's just see what happened when I did the distance here. Yeah, the distance squared is 25. The distance is 5. Remember, I built this up. First, I found the difference in the x's. Then I found the difference in the y's. Then I found the distance squared, which was 25, which I expected. I take the square root of that. The final step, the actual completed distance formula, calculated the radius as 5. When I called calculate area with those same points, and I calculated it within, called the distance formula from within, I got the correct value, because 5 times pi r squared, pi times 5 squared is about this. It's about 3 times 25, so it works correctly.